Welcome back. 6.1, Chapter 6.1, An Introduction to Angles. This is page 3, and this is where we start getting into the math, so this will take a little longer. This may be one that it is helpful to pause and repeat, depending on how comfortable you are with radians. You'll notice every time I add on a recording for a new page, the two previous pages are in here, so that we can refer back if we need to. So we ended that page 2 with the circumference of a unit circle, 2 pi. 2 pi once around the circle. Earlier we said that 2 pi was 360 degrees. So if we cut both sides of that equation in half, if 2 pi radians is 360 degrees, then 1 pi radian is going to be 180 degrees. We are going to use that fact to convert back and forth from degree to radian and radian to degree. Okay? So we have pi radians is 180 degrees. So let's take a look at the degree measure of 1 radian. So pi radians, and we don't always write out radians, I will for a little while here, is 180 degrees. If I don't want pi radians, I just want 1 radian. I'm going to divide both sides by pi, and we get 1 radian. Once we plug this into a calculator, and let's go with the squiggles, we're talking roughly 57.3 degrees. Do we use that fact? No, not very often. But it's there in case you see a need. To convert back and forth, we're going to use that unit conversion. 1 radian is 180 degrees. And actually, let me highlight this a little bigger because that is going to be used quite frequently. So let's convert some of these. A couple of things I want to point out. First off, typically we are going to leave these in the most simplified fraction. We are not going to convert to a decimal. We want this as exact as possible. So we have 60 degrees. I'm going to multiply by pi radians over 180 degrees. This is how I'm going to use that unit conversion factor up above. Sorry, momentary loss of words there. I want to point out that units cancel just like numbers do. So now I have 60 pi over 180, which we can reduce to 6 pi over 18. There is nothing that says we've got to go all the way down to start. 1 pi over 3 or just pi over 3. We are going to do this again. If you feel comfortable with that, perfectly fine to go ahead and pause this recording and then just come back and compare answers. Again, I'm going to cancel the degrees. I'm going to divide by 10 just to make this go a little quicker. (39 pi over 18). I know that 3 goes into both 39 and 18. So I get 13 pi over 6 radians. And I can label this with radians. Typically we don't. It's kind of implied if you see that pi in there that we are dealing with radians. I got negative 450 degrees. Again, times pi radians over 180 degrees. Again, I'm canceling the degrees. I'm canceling that factor of 10. 9 goes into both 45 and 82. Keep in mind we have this negative out front, so this stays negative. Negative 5 pi over 2. And since I have the room, I will add that radian label on here. Again, that one is definitely implied if we don't see a degree symbol. And we've got a pi in there. 90 degrees times pi radians over 180 degrees gives us 9 pi over 18, gives us pi over 2. Notice I don't waste a whole lot of time trying to figure out the largest thing that's going to go in. I just go ahead and go with what seems obvious to start and reduce from there. I got negative 27 over 18. So negative 3 pi over 2. Notice this is the same thing as negative 3/2 times pi. We typically go ahead and put that pi in the numerator. Make life easier for us. We talked earlier about how 45 degrees was half of 90. Sorry, I got a step ahead of me and I wrote 90 in that denominator. I'm sure you guys have already caught my mistake here. That is supposed to be, that's a multiply, 180. 45 over 180. Well, 45 times 2 is 90. 90 times 2 is 180. So 45 goes into 180 4 times, and we get pi over 4 radians. Notice I did not cram those radians in a couple places where it was getting super crowded in the notes. All of these do have a unit of radians. We will talk in the next couple of sections about how radians is really a unitless degree. So we'll go from there with that. To go the other directions, to convert from radians to degree, we still use that same unit ratio. This time we reverse the order that we're doing this in. We flip it. So now we've got the 180 degrees in the numerator. We've got pi in the denominator. Now this back part, replace pi with 180. We will take a look at what that looks like here with this first example, kind of show how it works. So I've got pi over 6 radians. I'm sticking that unit measure in the numerator. I'm going to multiply by 180 degrees over pi radians. Again, I said that units cancel just like numbers do. So the reason for putting that pi radians in the denominator is so it will cancel with the radians in the numerator. You notice here, because my initial angle was written with radians, I've got a pi in the numerator, also cancels with that pi in the denominator, which is why that replace the pi with 180s makes sense. 180 divided by 6 is 30. So pi over 6 radians is 30 degrees. Let's use that second method here. I got 7 pi radians over 8. I want to multiply again by 180 degrees over that pi radians. Again, it's this cancel here. 7 times 180 is 1,260 over 8. When we divide that, we get 157.5 degrees. Noticed earlier, no decimals when we're talking about radians. Perfectly fine to have a decimal measure when we're talking about the degree of an angle. Here, we don't always have nice and neat angles in radian measures. So I have a decimal, 0.8021 radians. Again, I am including that unit because I want to make sure that I multiply here the right direction. Apparently I can't talk and write at the same time. I'm going to start by putting pi radians in the denominator because I want those radians to cancel. If my pi radians in the denominator, I need my 180 degrees in the numerator. 180 degrees is pi radians. That's how we have that equivalence. I can multiply. I get 144.378 degrees over pi. When I plug that into the calculator, I am going to hit the pi button and not use 3.14. When I divide that, we get 45.96 degrees. Last one here. I've got 4 pi radians. Again, I go through these fairly quick, figuring that you can pause and rewind. I just don't want these recordings to end up being 20 minutes long each page. When we cancel our pi radians in the numerator and denominator, we get 4 times 180 degrees. 4 times 180 is 720 degrees. Keep in mind that is 2 times around the circle. 2 times 360 is 720, so that all matches up. 9, we need to get comfortable using angles in radian measure. For the most part, we're going to talk about trigonometry using radian measure. There will be some time that we talk in terms of degrees, but that is going to be referring to a rotation, a degree measure in slope. Typically, we talk about radians because we want a linear measure. We want each angle in standard position. We want to name the quadrant in which the terminal side lies. So let's see how much information I can add in here to help this make sense. So here's my initial side. In standard position means that initial side has to line up with the positive x-axis. Right? So there's my first little piece here. And let's see if we can coordinate. Standard position means we are starting with that positive x-axis. Okay. We have a negative angle measure, so we know we are moving in the clockwise direction. Question is, where does pi over 6 lie, and how do we figure that out without having to always convert to a degree? Okay, now, here's what I'm going to say. In the negative direction, we know if we go all the way to the negative side of the x-axis, that's 180 degrees or negative 1 pi. Negative pi. If I need 6 in the denominator, that means that's my negative 6 pi over 6. So the bottom half here, this whole bottom half of our coordinate grid is negative 6 pi over 6. So if I need to figure out where negative 1 pi over 6 is, I'm going to go about 1/6 of the way. And just a reminder about how we label our quadrants here. This is 1, 2, 3, and 4, so that negative pi over 6 ends up in quadrant 4. 3 pi over 7, again, we are starting on that positive x-axis. There's my terminal side. I need to do a little fraction comparison here. I know that 90 degrees is pi over 2. And even though it's not an official way to write it, if I wanted a denominator of 7, I know my numerator would be 3.5. 3.5 is half of 7. So if I were comparing that pi over 2, my 90 degrees, 3.5 pi over 7. 3 pi over 7 has got to be a little less than that, which means I don't go quite all the way to 90 degrees. So we are going to put that roughly here. Again, I'm not worried too much about exactly where it would lie. We just want that general picture. This is a angle with a terminal side in quadrant 1. Last one, negative 4 pi over 5. Here is my initial side. I know that I'm going in the negative direction, and I'm not going all the way to the negative side of the axis. That would be negative 1 pi or negative 5 pi over 5. So I'm going to stop short of that. Again, I'm eyeballing what 1 pi over 5 looks like. Here's my negative 4 pi over 5. And we end up in quadrant 3 with that terminal side.